This is a demo of using Simulink connected directly to ArduPilot. So I've got a basic rover model here, so I will just start this up. And as we did with normal MATLAB, I'll just start SITL here with tag F JSON and then again the IP of the address where Simulink is running. So you can see it's connected already. It's not quite as obvious as plain MATLAB because we don't get the printout, but if we go here on diagnostics, you get the same printout that we were seeing in MATLAB, so it's the frames a second. And in this case, I'm straight away running at, I'm attempting to run at 5 times speed up, but because Simulink is a bit slower than flat out MATLAB, we're not achieving that, but otherwise this rover example, it would be very boring. It's quite slow. So I thought I'd also connect Mission Planner here. So I've just connected with a TCP connection. And I actually have a mission already loaded. So let's just read that back. So it appears on the map here for us. There it is. So let's arm and then switch into auto. So off goes our rover. So let's just have a look at how this model works. So on the left here, we've got a block. So this is receiving from ArduPilot. So it receives the PWM signals. There's 16 of them. We're just taking 2 here. So we've got a left and a right motor. And then this little box is the entirety of the rover physics. This is from the robotics toolbox. It's just a differential jive kinematic model. So you've got a left motor and a right motor. So that does all the physics for us. And then there on the far right here, we've got an output block which takes in a gyro, an attitude, an acceleration, a velocity, and a position. And then we send that back to ArduPilot. So in this instance, we only have an X and a Y position here, and we've got X and Y velocity, and they happen to use a different reference frame. So we've had to put a minus in here to get that correct. And obviously we've got no Z height on our rover. Then we can take the heading, and I've actually had to include this function, which is just a wrap function, because this physics for the robot doesn't wrap pi for us. So you end up with an increasing heading. So this just wraps it back so it stays between 0 and 360 degrees. Again, it happens to be negative, and we've got gyro. So one of the issues with this model, well, one of the shortcomings perhaps is that it actually doesn't have an acceleration, and this is because we're directly inputting the wheel speed. So because we're directly inputting the wheel speed, you get infinite accelerations basically when there's a step change in velocity. So this is actually running with EKF type 10, which is directly reading the velocity, position, attitude from SITL without running the EKF in the background, because the acceleration here, so I've set it to nothing gravity, but this isn't a good enough approximation for to keep the EKF happy in this instance. But if you had a model that did acceleration properly, you could feed that in here and you should be able to run with the full EKF, no problem. So let's just have a look at these 2 connection blocks. So I've actually made a little library here. So we've got the reading from ArduPilot, PWM, and reading out. And actually there's a reset pin here, and you can see I've not used it. So this pin will actually, it's a logical output. So it will be set true if you've reset SITL. So in this model, I haven't bothered to add the blocks that would reset the position and velocity back to 0, but you could do that if you wanted to. So this is just a function which is essentially the same as the connection function we used with plain MATLAB. And then I've got these 2 rate disconnects, which means that the actual physics of the model can run at whatever time it wants. And in this case, we're actually using a variable time step solver within Simulink. So this just disconnects the actual communication from the variable time stepping that Simulink does. And then again, if we have a peek at the output, again, we've got these rate transitions to deal with Simulink doing whatever time step it likes. And unfortunately, this means that you can't, as we were doing with plain MATLAB, we had this new parameter, sim_rate, rate. Oh, there it is. So actually, for Simulink, it doesn't actually work, this parameter, because Simulink is picking its own time steps for this example. So, but what does work is the speed up. So if we go sim speed up, and as I said, it's actually set to 5 here, but because Simulink is a little bit more inefficient than MATLAB, we're not reaching it. So if I just put it back to 1, and we get up, this is what SITL is reporting, we should straight away see it's gone back to 1, and now our rover will be moving much more slowly. So I'm a bit of a Simulink beginner, so if anyone has any ideas how we can improve this, that would be great. So one of the problems I'm having at the moment is if I press stop, actually it doesn't necessarily stop. So it stopped here because ArduPilot was still connected. So if I just restart this, again it connects no problem if you stop either side. But if I stop ArduPilot and then I press this nice stop button, it no longer works, and that's because it's stuck waiting. It's in the while loop in the function here, waiting to get data. So the only way to stop it is to go and Control-C in the terminal here, which is what we had to do for the other connector. But it's a bit of a shame when we've got the nice stop button up here if we can't use it. So if anyone has any ideas or any more interesting models we could try out with this same connector, that'd be great. Thank you.